Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are continuing our journey into sequences and series. Gonna get series this. Yeah. Sorry. All right, we're gonna talk about series, and then in our next videos, we'll talk specifically about arithmetic and geometric series. Let's get to it, shall we? Okay, so what is a series? It's very simple. A series is the sum of the terms of a sequence. So it would just be, so if I had the arithmetic sequence 1, 3, 5, 7, then the series would be 1 plus 3 plus 5 plus 7. That's all a series is. It's finite. If we stop at a particular place, like here, I stopped at the fourth term 7, then if it is finite, it'll be a finite real number. For an infinite sequence, it just keeps going and going and going. And a lot of cases, you can't calculate it. But in some, we can calculate the sum of an infinite series. That is exciting. I know you can't wait to get to it. Something quite important. It's called sigma notation. And if you saw it right here, this is a general term. And then it gives you a specific one here. Here's another one right here. We'll get some specific ones here. Instead of writing out each single term, we can use sigma notation. This is the Greek letter sigma, okay? It's the S in the Greek alphabet, and we can write u sub 1 plus u sub 2 plus u sub 3, blah, 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 all the way to u sub n as the sum, here we go, the sum of all numbers of the form u sub k, right here, where k equals 1, 2, 3, up to n. Again, these are always going to be integers. Okay, so let me say that again. This stands for the sum of all numbers of the form u sub k, where k is equal to 1, 2, 3, all the way up to n. So how does that work? Well, we start at 1 right here and say it's u sub 1 plus u sub 2. After 1 we go to 2, and we just keep counting up. If this were a particular number like 4, from k equals 1 to 4, then we would stop right there. But to n, that's going to be infinite unless we have something very specific. Let's do some examples. Okay, so for part A, consider the sequence 1, 4, 9, 16, 25. Write down expression for the sum of those numbers. So here they just say S sub n. Okay, that is going to equal, so this is going to equal 1 plus 4 plus 9 plus 16 plus 25 plus boom, boom, boom. And that's all there is to that, writing that sum. Well, we can use sigma notation if we recognize these as perfect squares. We can write these in the form. Okay, we use the sigma here. From k equals 1 to n, because this doesn't end, right? Well, k is going to be our variable, k squared. So when k equals 1, I got 1 squared. When k equals 2, I get 2 squared, or 4. And then k equals 3, 3 squared, and on up the integers, or the counting numbers. 4 squared is 16, 5 squared is 25. And then it goes forever and ever and ever. We just indicate that with the 3 ellipses here. Again, if this were like a 5, we would have stopped right here at 25. So here it says find S sub n for 1, 2, 3, 4, and 5. Well, let's see, S sub 5 would simply equal the sum of all those, which would be 1 plus 4 plus 9 plus 16 plus 25, which turns out to be 55. So S sub n for these is going to turn out to be S sub 5 since there are 5 terms, which means the sum of the first 5 terms in this particular sequence. The important thing is that you will understand how to use sigma notation. So I'm going to give a particular one. Let's say we had from k equals 1 to, we'll do 5, of 2n. Well, this would equal 2 times 1 for k equals 1, and I'm going to use my counting numbers up to 5, plus 2 times 2, replacing, oops, this should be a k, so sorry, because this was a k, this should be a k. So replacing k with 1, replacing k with 2, replacing k with 3, replacing k with 4, and replacing k with 5, which is equal to 2 plus 4 plus 6 plus 8 plus 10. This is a 10, 20, 30, so that equals 30. All right. Okay, let's try out this one. Expand and evaluate. Kind of just did that. So we have the sum from k equals 1 to 7 of k plus 1. So that's going to equal 1 plus 1 is 2. So that's for k equal to 1. For k equal to 2, that's going to be 2 plus 1, which is 3. So I'm just going to have 7 terms. You can see what the pattern is. It's just going to keep increasing by 1, and there's 7 terms. 1, 2, 3, 4, 5, 6, 7. So I have to add these up. 7 and 3 is 10. 8 and 2 is 10, so that's 20. 29, and then 9 more is equal to 30. Oh, wait. Did I do that wrong? Yes, I did. 1, 2, 3, 4, 5, 6, 7. What did I do wrong? 2 plus 3 plus 4 plus... Oh, I forgot 6. I'm such an idiot. Plus, sorry about that, 6 plus 7 plus 8. That sum is 35. Okay. And then for B, they want me to do the sum from k equals 1 to 5 of 1 over 2 to the k. Well, that's going to equal 1 over 2 to the first power plus 1 over 2 squared plus 1 over 2 cubed plus 1 over 2 to the fourth plus 1 over 2 to the fifth. And that's equal to 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. So our common denominator is going to be 32. So that's 16 over 32 plus 8 over 32 plus 4 over 32 plus 2 over 32 plus 1 over 32, which turns out to be 31 over 32. Now, you can also do this on your calculator. And to do that, you just go, a lot of things are right here on this button, including the sigma. There it is. So I have it. So I can do from x equals 1. Oops, it already has the equals for me. X equals 1. Let's go to that one. To 7 of x plus 1 entree, and there we go. We have the 35, and I'll just go up and copy that so I don't have to find it again for the next one, which is k equals 1 to 5 over 2 to the k. I wonder if, well, no, I won't mess with it. So 1 to 5 of 1 over 2 to the k, right? So 1 over 2, and I used x here. See what we get. Ooh, we get a decimal, which is fine, but did you know you can convert this to a fraction? Menu, number, approximate to fraction, and it'll give us a nice fraction as well. Okay, so let's get those on there for you so you can have that in your notes. Okay, all right, so one last thing real quick. Here's some properties of sigma notation. So if you have the property of the sum of two things, you can split those, which makes sense. You don't have to do them at the same time if you don't want to. If C is a constant, then you can factor out the constant, and or you can just if you just have the sum of a constant, it's equal to C times whatever that is. Whatever the value then is. Okay, so hope you enjoyed that. I certainly did. We're going to go out with a little more ELO, see how they're doing. They are doing great. Electric Light Orchestra, great band. And with that, I am out!